Greetings, friends, with my friend here again, who you know, and today we're going to be talking about Venus, the planet Venus. One of the questions might be, why is Venus so hot? But you know, it's kind of a loose format here. We may talk about other things like how do we know what we know? What are the prospects for humans settling on Venus? The main thing they talk about is Venus being a very hot planet. And you start off here by talking about the geology of the Earth, how if the Sun is considered the only source of heat, then an object at Earth distance from the Sun can only have a maximum temperature of about 120 degrees Celsius. And then the Moon, which is in a vacuum, reaches this temperature in direct sunlight.
The heat from the sun is 1,370 watts per square meter.
Oh, okay.
Be about what your electric wall heater would put out.
So you pose the question, then why then do we have molten lava at more than 1,200 degrees Celsius or 2,192 degrees Fahrenheit? And you mentioned that there is some low-level radioactivity in rocks,
yeah,
mostly uranium in granite,
yeah,
which keeps the Earth from cooling down.
Yeah.
This is counterintuitive and needs an explanation. So maybe you could help us understand what's going on underneath the surface of the Earth, because I never knew what makes lava, or I guess they call it magma, because magma is underneath, hasn't been exposed. I always thought it was just the gravity of the Earth, or I don't know, something just gets hotter the farther down you go into the Earth. But you're saying here it has to do with radiation from uranium.
It's background radiation. Okay, the Earth should have cooled off long ago, and there wouldn't be any lava. The interior would be warm, but you wouldn't have volcanoes like Krakatoa.
Right.
That was explosive power of 100 megatons of high explosive, right?
Right.
But that comes from somewhere, and that's just a gentle sort of background radiation. The heat builds up over the billions of years it's been there.
Right.
So it's counterintuitive. You know, where does all this heat come from?
Yeah, it's kind of strange. I never quite
it doesn't
understood
make sense.
it. Yeah.
But it's like big. Like when you have surface area goes up to the second power, and the volume goes up to the third power. So when things get big, they get hot because you can only radiate through the surface.
Interesting.
Okay. Like a skinny guy like you is going to get colder faster because you have more surface.
Oh, I see. So all that mass.
Yeah. With the background radioactivity.
Right. Interesting.
Also, you can type atomic bomb. They get the material from that, and from the Earth, and that's that energy. When they put it together, it makes atomic bombs.
So there must be a lot of uranium in the Earth. It's causing all the molten. Yeah.
1 part per million.
Oh, so not that much then.
Not that much, but it's all distributed. It's all
okay, because they have to mine that material for. But the uranium is radioactive on its own. It doesn't become radioactive from being in the surface of the Earth. It's just a naturally radioactive.
It's been radioactive for the last 5 billion years.
Okay.
If you mix it with water, coffee, if you burn it, it's still. That's the thing about radioactive things. It doesn't matter what you combine them with. It's always radioactive.
So you were saying the low level of radioactivity in rocks keeps the Earth from cooling down. This is counterintuitive. This needs an explanation. Temperature depends on kinetic energy, which is measured in electron volts. Uranium decay releases 200 million electron volts of energy, while chemical reactions, such as fossil fuels, release less than 10 electron volts.
Yeah, so that's unit of energy, like when you go to the dentist,
Right.
that's 70,000 electron volts. It drives the electrons through your mouth and into the photographic film there.
You mean one of the implements that the dentist uses?
It's when you get an X-ray.
Oh, an X-ray. Oh,
the dentist.
okay, the X-ray. Right.
So that you have different. You can compare these different energies.
So basically you're saying that the uranium decay is releasing astronomically, like way more energy than chemical reactions.
Yeah, that's why they use it for the nuclear power
Right.
plant.
We therefore have a small amount of heat at a high temperature. And so heat can be transferred by radiation, convection, and conduction. Within the Earth, the first two are impossible, while the last, conduction, is very slow. So here is what we have. For each kilometer that you go down into the surface of the Earth, or into the crust of the Earth, the temperature goes up about 25 degrees Celsius per kilometer. So in other words, this is a small amount of intense heat leaks out very slowly. Uranium has a half-life of about 4.5 billion years, so that there would have been as much as twice as much heat in the past. Perhaps this would balance out the reduction of solar radiation in the past, around 70% less. Can you help me understand that last part about balancing out reduction of solar radiation?
There's it's a typo. It should be 30% less.
Oh, okay.
But when the sun's younger, it's burning hydrogen, and then when it starts burning helium, it expands and gets heavier, and it puts out more heat. So it's putting out more heat in the past. So if it's 0.7, then everything would be colder. There might be all ice ages in the past. But
Right.
that's long ago. It doesn't really affect the age of the dinosaurs. That's only
Right.
100, 200 million years ago.
So so the purpose of talking about this, the production of heat in the Earth, is so we can compare that to Venus?
Yeah, that's where we're going. Okay,
Yeah.
one little thing. This
Yeah.
is not my original idea. It's in the textbook with calculations.
Right.
It's at university websites. It's on
Right.
Wikipedia. The heat of the Earth, at least half of it, comes from the decay of radioactive things, uranium,
Right.
thorium,
Right.
a bunch of things.
And then you talked briefly about carbon dioxide. Billions of years ago, there were only trace amounts of oxygen in the atmosphere. Was that on Earth or in Venus? Venus?
Okay, so both.
Both, yeah. And then carbon dioxide under pressure dissolves in water. Water becomes acid, which dissolves certain minerals so that large volumes of carbonate rock form. For example, dolomite.
Yeah. So the carbon dioxide dissolves in water. It's sort of like vinegar and baking soda. It forms a slush. So if there's no water, you have this carbon dioxide. On Venus, the atmosphere is nearly 100 times thicker.
Right.
It's like being a kilometer down in the ocean.
Right.
Okay, so we had carbon dioxide, but we had water, so it forms rock.
And now we get to Venus. Venus, it's the next closest planet to the Sun, then after Earth, because it goes Mercury, then Venus, then Earth, then Mars. So it's very similar in size to Earth.
Yeah.
Just a tiny bit smaller. And it has no water on Venus that we know of.
Pretty well known.
Maybe some gas.
It has some trace, but...
And it's an extremely hot planet because of all the atmosphere, the extremely dense atmosphere. The surface temperature, you say, is about 400 degrees Celsius.
460 over that, or 860 Fahrenheit. It's hotter than your oven.
Yeah, because you can bake something at 350 in the oven, or maybe 450. So that would be right in the middle of the oven.
It'd be on the burner. If the oven was that hot, it would start a fire.
Right. And you mentioned that, well, there are volcanic eruptions on Venus, but they're not really big explosions because of all that atmosphere.
Yeah.
So that produces smokers like we have at the bottom of the ocean on Earth.
Okay, except that the smokers, they're fed by water vapor and then explodes out. There's no water on vapor, so there's just
Right.
sort of sulfur or maybe carbon dioxide coming out to be.
On Venus.
Yeah, yeah.
It's not magma, it's carbon. What were you saying comes out of the volcano on Venus?
A gas.
Oh, okay.
When you have a big explosion like Mount St. Helens,
Right.
there's water vapor trapped in there, and when it gets heated up, it will expand from 500 to 1,000 times greater.
Right.
And that's like a high explosive
Yeah. Yeah, it would be.
when it suddenly breaks out.
Yeah. So that couldn't happen on Venus. Too much atmosphere there.
Yeah.
And also the one last thing I should mention is that it's rotating much more slowly than the Earth.
And it rotates backwards. Yeah.
Oh, right, yeah.
243 of our days is one of their days. So
Yeah, wow.
So there's a question, did it something bang into it? Because all
Right.
the other planets are turning around and
The axis of Venus? No, I'm thinking of a different planet. I'm thinking of Uranus or other planet.
Uranus is on its side. So,
Right.
but all the inner planets and,
That's interesting. So it's rotating the other way.
well, it's hardly rotating at all, so it's possible something smashed into it. And
So it has a 243 Earth day as their day
Yeah,
when they're in the sun.
yeah.
Presumably sunlight could reach the bottom of the planet.
It'd be very dim light.
Right. But then does that mean the night is 243 Earth, like the
Well,
night is going to be 243 Earth days too?
you divide it into 120.
Yeah.
Okay, so it'll be
Right.
night for 120 days. Yeah, yeah,
So that would be a long time in the dark. Yeah.
yeah.
Further details. We mentioned there's no liquid on Venus. The surface is at the melting of sulfur, but this evaporates. So you mean the surface is hot enough to melt sulfur? Is that what
Yeah,
you're saying?
it's 462 degrees Celsius.
Right.
It would melt the sulfur,
Yeah, go ahead.
but it would be like water on the sidewalk. It evaporates.
Right.
It's possible to have liquid sulfur, but it's the pressure would have to be higher or the temperature lower.
So no clouds until the elevation is about 30 kilometers above the surface. That's very high.
Yeah,
That's not like Earth.
No,
Earth, the clouds are very low, or they can be.
there'll be about 1 kilometer.
So why are the clouds so high on? Or is that just sulfur clouds?
The mostly sulfur and all sorts of things.
Why is it so high above the surface and not like Earth?
The atmosphere is about 100 times greater to start with.
So it's just a thicker atmosphere.
It's a thicker atmosphere, and like when the air goes up, it cools, and you have clouds at a kilometer. The sulfur doesn't come out precipitate until you're 30 miles up. It's still pretty hot.
I don't quite understand why, if you have a thicker atmosphere, wouldn't that mean there's going to be more clouds closer to the bottom because there's nowhere else for the gas to go?
It has to condense, and it doesn't condense until it cools off.
Oh, I see. Okay.
It's just,
It needs to condense at a higher elevation.
yeah, because it's just so hot.
And then we mentioned that the long day, 243 Earth days, and then the mass transport of energy on Earth, like tornadoes, hurricanes, this does not exist on Venus.
Yeah,
There's no water, so there can't be well, there's barely any water.
Yeah.
Heat can only drift up in a slow, leisurely manner, which is referred to as adiabatic lapse rate.
Okay. Adiabatic and adiabatic.
Adiabatic, yeah.
Okay, you can pronounce it two ways, but lately they're doing adiabatic.
Okay. What's that? Yeah.
Okay, that means you have some air and there's no heat in or out of it. It goes up, expands, and cools when it goes up in the air. Okay, so if you have this much energy, then it goes up, it's spread over and it cools. You're supposed to say that it does work on the outside and then it cools off, but anyway, it cools off.
Okay. For terrestrial planets, this is usually, I guess the adiabatic lapse rate is usually a bit less than 10 degrees Celsius per kilometer.
Yeah, so when you go up a kilometer, the temperature goes down 10 degrees.
Right.
As long as it's dry air. If it's humid, it gets complicated. Clouds form and all that.
Right. And just to conclude this technical section, 50 kilometers above the surface, the temperature is about 60 degrees Celsius.
Yeah.
Which is still pretty warm, but much more manageable.
Yeah.
The upper atmosphere on the dark side of Venus can have a temperature as low as minus 170 degrees Celsius.
Yeah, there's no sun for
Right. 243 Earth days.
Oh, 120 days or whatever.
Oh, okay.
The night, whatever.
Let's get to how this information, how do we come to know these things about Venus? Like,
okay, there's about 15 Russian probes go to Venus 1967 to 1984.
Okay.
And there's American probes. They've been there, done that. Nobody's moving in anytime soon.
Right. So it began probes going there in 1967, the Soviets.
Yeah.
And the Americans around the same time.
Yeah.
But before 1967, what did we really know about Venus? Just through telescopes and astronomers, and there wasn't really much
I don't know. At one time they used to think there were canals on Mars.
On Mars, yeah, right.
There was an Italian astronomer and he thought he saw canals and everybody thought they were canals, and then Gustav Holst wrote the Symphony of the Planets.
Right.
And the March from Mars is the best military march that I've heard so far.
Right. So these probes which went to Venus, the Soviet, were they not all? Presumably, some of them were just flying by. Some of them attempted to land.
One of them landed.
Oh, okay. When was that one?
I don't know the date, but it was
in the 70s.
In the 70s.
Yeah. I saw the photos it took. It was interesting.
The electronics they burnt out after half an hour or so. You can't get away from the heat. There's no air conditioner.
Did they try to land maybe some other landers, but then it failed, or
they landed, but like I say, nobody's going there anytime soon. It's just too hot, and you could float around in a Zeppelin.
Right, a Zeppelin, yeah.
It's cool, but if it goes down, you're dead. There's no rest.
So, for people who are real skeptics of all this stuff, how can we say that Venus is real, or that planets themselves are real? Because aren't we relying on a small number of people to give us this information?
Well, China.
We don't really know if are they acting in our best interest in telling us these things.
They're acting in their best interest, but anyway, China landed a rover on Mars.
Oh, they did? I know they landed one on the moon. You mean the moon?
Yeah, one on the moon and one on Mars.
Oh, really? That's news to me. When did they land the one on
Mars? Mars, not too long ago.
Oh, okay.
I just caught it, but I didn't.
Interesting. So they're doing that now.
So
it would take a big conspiracy of all the world governments to fake that planets are real things, or if they're not.
They were talking about the planets hundreds of years ago.
Right.
They would say, well, what kind of musical tuning would they have on Mars? They were actually saying those things.
Right. Musical tuning. But did they conceive of planets back then as things that you could actually walk on? Or were they just more like things up in the sky, the lights
Well,
or
Newton's
something?
law of gravity, he could calculate how big things are. He calculated how big the moon is.
Right.
And so they do some people just love to do calculations all day long.
Right.
So they have an idea how big the things is with Newton's law of gravity and like that's almost just before 1700. So
Right.
they would have a good idea what's there, but they'd have no way of getting there, of course.
It just seems like a very far off world that we can never really get to. So I can see how some people might not believe that these things are real, but I don't have a strong opinion on it one way or the other.
Well, they could set up a prison camp on Venus, like a
Right.
floating prison camp.
Right.
There's nowhere to escape.
That's one thing we're going to get to when we conclude this, is the actual prospects for settling. But just on the whole skepticism side, like why didn't they take more photos of Venus? Because their lander got burned up, I guess. They haven't had any other chance. They can't even have any photos like flying by, or like I looked on the internet. There's barely any photos.
All you see is
Venus.
this cloud.
Right? Yeah. Just a big cloud.
Yeah, it's clouds from 30 miles up to around 50 or 60 miles.
Right. Oh, and here's another question I should have asked in the beginning. It's like, so where did all that atmosphere come from? Like, why does it have such a thicker atmosphere than Earth?
Okay,
So you don't really
because Earth has water, and we mentioned it. The water dissolves carbon dioxide.
Oh, I see. Okay.
And when it's under pressure, like Coca-Cola, it dissolves a lot of it. It becomes acid. It dissolves the rock, and it makes a slush. The slush goes to the bottom. It gets compressed, recycled.
That's what happens on Earth because of the hydrological cycle. Okay, so no water on Venus means that the water can't be filtering out the heavier elements, the CO2.
It can't dissolve the carbon dioxide.
Right. So the Venus's atmosphere is heavily CO2 and other sulfur or whatever.
Yes, unless there might have been some catastrophe, because it doesn't make any sense. The planet should be turning around like Earth and Mars.
There were just a few photos from the surface from that Soviet lander, and I mean, I guess who knows if the Soviets were telling the truth, but I guess it could be a real photo of Venus, but it definitely looked really odd. Like the color in the background was very strange, like yellowish or greenish.
There's no
the soil.
Very little sunlight except for this yellow light from the clouds.
Yeah.
And then there might be a reddish background because it's so hot.
The ground where the lander landed was very dark, almost charred looking.
Yeah, it's very little sunlight gets in.
Right.
So the whole thing is dark at the surface.
Interesting.
Like twilight.
Like a twilight.
Yeah.
Okay. Not like Mars, where Mars looks similar to Earth, to the southwest.
You get 3 rocks, that's all.
Right. Yeah, some rocks. They couldn't take any rocks back home, I guess, but...
I know they couldn't blast off because the electronics were all fried in half
an hour. Right. So why is the rest of the solar system so barren? Why is there no life, or even any, if not life, at least more hospitable, circumstances on other? Why are all the rest of the? I mean, I guess it has to do with how close to the sun you are. That has a lot to do with it. But what would you say to that?
There was a big disaster on Venus. Something hit it and blew away all the water. There might have been life before, because it'll do just fine in sort of smelly sulfuric acid stuff. And they think there's chemicals there that indicate life, but it doesn't make any sense. There was probably some sort of disaster there that...
So you think there could have been life there in the past? That's what they say about Mars, for some people.
Yeah, okay, there
I don't
was
know.
water there. The planet might have cooled off, it's smaller. See, if there's heat coming from the ground, it might have kept it warm, but there was liquid water there. Nobody knows if there's life, so there's...
Not anymore. You need water to have life.
Something like that.
Right. Now, in terms of the prospects for human settlement on Venus, what are the main, well, we've talked about, well, some of the main challenges are obviously the intense temperature on the surface. You wouldn't be able to breathe the air, but well, you'd be boiled alive.
Yeah.
And the pressure would be enough to make life very uncomfortable.
People can't live at that pressure. I think it would crush their lungs or something like that.
Yeah, right.
So you'd have to be in a capsule.
Because it's a shame, because they say that in other ways Venus is a much better candidate for human settlement than Mars. Because Mars is only, like, what, about 1/3 the gravity of Earth?
Yeah.
And so it has such a thin... Mars is the opposite problem. It's extremely cold. It has a very thin atmosphere. And you can't live at low gravity without having problems with your bones, circulation, digestion, let alone giving birth. Let alone the longer distance, the longer travel time to reach Mars compared to Venus.
Yeah.
Venus is a shorter travel, but the main idea that Venus is so close, like they call Venus the sister planet to Earth because it's so similar in size and gravity that you would theoretically be similar to. I mean, again, I know I'm relying on all what these priestly class of scientists are telling me, so who knows what's the truth, but I'm just saying based on what they're telling us, it would be a much more, but then there's these barriers because of the heat, so...
The only thing you could have is this sort of floating ship.
Right.
That would work, and then it'd make
They'd have to have, so these floating blimps up in the Venetian is that a word, Venetian, or no?
Venetian atmosphere.
Right.
But it has to be about 60 miles up, and you cannot have a platform that high because the steel at the bottom would get soft and melt and sag.
Oh, really?
Because of the heat.
Wow.
So you can't build the Tower of Babel
right
on Venus. So to be speaking one language there.
Right. So that leaves us with the question: would there ever be a way to change the atmosphere, like change Venus so that it could be habitable? Change the atmosphere, get rid of all that excess carbon dioxide.
You'd have to dump a lot of water in there.
Interesting.
And there's no water tankers. It's just, I don't see a way of doing it, and you can't go into the ground because it'll just get hotter as you go down into the ground.
But the prospect of that happening is very low, and it'll probably never happen.
No.
I don't know if humans are actually going to be colonizing other planets. I don't know if that was ever part of the cards.
Okay, so what if Earth didn't have any water?
If Earth didn't, I guess then it would start to look like Venus.
It might, because maybe a comet or meteor could just hit the Pacific Ocean,
Right.
knock off all the water, cloud of vapor,
Yeah.
and then there would be dust for a long time. Anyway, if there's no water, then this heat comes from the ground. You have a ring of fire around the Pacific Ocean, the lava would come out and there wouldn't be any water to cool it off. You have the mid-Atlantic Ocean ridge. And then the carbon dioxide in the earth and the rocks would go back into the air, and you might end up with the same thing as Venus.
Right.
All the water, some alien came along with a straw and sucked all the water out of the ocean.
Right.
Might have to fight for our water.
I feel like Earth has too much water. Well, I mean, it has not in the right place. I know, like, water is going to become a scarce resource for a lot of the world. But we have plenty of water in the oceans. It's just salty, so you can't drink it. But we have quite a lot of water.
Or you can desalinize it. And I don't know, I think there's lots of room, just everybody wants to come here or whatever.
Yeah. Canada has a lot of water. We have more lakes than I think any other country in the world. So I know there's always going to be people doubting the moon landing, but while we're on the topic of planets, like, let's assume that the moon landing did occur. I know a lot of people question it, but what I want to know is how did the astronauts, how were they able, because there were different missions that went there, but they spent some of them spent a few Earth days on the moon.
Yeah.
How were they able to sleep there, eat there, digest? Like, how are they able to last even a few days there?
You just float around, so you just sleep wherever you're sitting, standing. You can sleep upside down if you want.
Yeah, that's incredible.
So you don't need gravity. You after a while your bones will dissolve into your body fluids, but that's not going to happen for.
Your bones will dissolve into your body fluids. Yeah.
You'll be a blob or something. So
well, you'd probably be dead before that.
You'll be fine for a week or so. So the whole thing is over and done with in less than 2 weeks. Okay?
Yeah.
And then the rocket that launches them, I mean, it's huge.
Yeah. That's incredible. I don't know what's true. It's hard. If we trusted our governments more, then we could have a better idea of whether these things happen, but I don't know.
Well, we could have a colony on the moon, and you could do videos up there.
Right.
Okay. You see if there's a job for a space cadet. I'm sure they'll take you.
The truth, I heard that a lot of the surface of the moon is pulverized glass, like a large, like 20% of the soil on the moon.
It's just sand.
Yeah,
And
but I heard that a large proportion of that sand is pulverized glass.
It's quartz.
Oh, okay.
So
It's not the same as glass, though. Somewhere I heard that.
no, you have to use some sort of chemicals to put into the.
There definitely is some reason that the rest of the solar system is so inhospitable. Even if you don't believe in planets, then that's still the same idea, that there's nothing hospitable out there for humans to live on. And I don't know what the answer is, but there must be some deep reason why it is like this.
You have to work harder, that's all, and it costs more money.
Yeah.
Venus is impossible, but the moon, you could have little colonies there, and Mars, but some of the moons of Saturn and Jupiter.
Yeah, the moons of Saturn and Jupiter, but you could never land on Jupiter or Uranus and Saturn. Those are all gas planets, right?
Yeah.
Not real planets. So what I want to know is there anything solid in like, is there a solid core somewhere within Jupiter or Neptune or Uranus?
Yeah, there's a solid core, but you'd have to go through so much liquid, the pressure would be unbelievable.
Yeah, it would be like traveling to the center of you'd be completely disintegrated. But there is theoretically, because like meteors are asteroids or comets are swallowed by Jupiter sometimes.
Yeah, so
that presumably crashes right to the central core. So there is something in there. they know how big the core is compared to the overall size of Jupiter?
Well, I think this is academic. There's just
They don't really know.
no way.
No one really knows a lot of these things.
You're not going down there. It's a huge planet, and if it was a little bit bigger, it would burn like the sun.
Right, right. Is Jupiter like a proto-star? I
Yeah,
don't know.
like a protostar.
It didn't have enough mass to become a star.
Yeah, it's mostly hydrogen. It's strange where these things come from. Planets are rock, it's gas.
Right.
It's too hot, it's too cold.
Interesting. Well, we've had a meandering discussion. Did you have any final thoughts?
Nope, we had a good discussion.
Yeah?
And,
Yeah?
we won't be going there anytime soon.
No, we won't be going to Venus anytime soon, so that's interesting to think about.
Okay, so
All right.
you done with this?
Yep. Hasta luego, amigos.